What is the difference between physical and chemical properties? Who can remind us? What is the difference between physical and the chemical properties?
When we talk about chemicals, we talk about the electrons. When we talk about physical, we talk about the outer or the
That we use our senses to detect it. Yes. Excellent. Thank you. So once we are speaking about chemical properties, so we are speaking about electrons. So if we are speaking about electrons, so we are speaking about losing and gaining and sharing. So chemical reaction happens. And this is the point of chemical reaction. The chemical reaction that we can see and play with it and see explosions, these kind of things, they are already the losing and the gaining and sharing of electrons together. So here we are going to try to see the chemical properties of metals and how they are different from the chemical properties of non-metals. So we are going to start doing an experiment. I believe this experiment we made it last year. I don't have it for this year. Anyway, so we are going to use a magnesium stripe. We are going to take just a piece of magnesium element, and we are going to add to this magnesium. The magnesium is the metal sample we have. Then we are going to add dilute hydrochloric acid. We are taking hydrochloric acid. Who can remind me the symbol for hydrochloric acid? Hydrochloric acid. How can I write it?
HCl.
HCl. So we are using the dilute hydrochloric acid or the HCl, adding it to the magnesium. What is the symbol for magnesium?
Mg.
Mg. Yes, Mg. So we are going to add the metal that is magnesium Mg on the HCl and see what will happen. I want to write Mg. Plus HCl. So a reaction happens like we are going to see something lighting, okay, and something like fire, but it's more like light comes out. So when we put the piece of magnesium strip and the test tube and add some dilute hydrochloric acid, this reaction happens and some gas bubbles comes out from this test tube. What is this gas bubble? So they said that once the active metal, any active metal, it can be magnesium, it can be zinc, it can be aluminium, any active metal combine with the hydrochloric acid, the hydrogen gas comes out, the hydrogen gas that is here. Okay, because you already know from last year that all the elements enter the reaction must go out from the reaction. They will not be lost. So this hydrogen will come out here. Okay, so we have here the hydrogen comes out H2, and I have as well with the hydrogen the salt will be formed. Do you remember what is the symbol for table salt? The table salt. What is its symbol? Salma. Table salt. How can we write it? No, you know. What?
I don't remember it.
Both sodium and chlorine together. So it is sodium chloride. How can I write sodium chloride?
NaCl.
NaCl. Do you remember it, Salma?
Yeah, I remember just now.
Yes, it's NaCl. Okay, this is table salt. So it's generally this is we are saying it is the salt that comes out from the acid here. So when the magnesium combine with HCl, it forms MgCl. This is salt as well, but we are calling it salt of acid because it comes from the acid. Because this magnesium combined with this chlorine in the acid, forming the salt of the acid, MgCl, and the hydrogen gas evolve. Okay, but of course this Yes, this equation need to be balanced. Who can balance it? I have Mg plus HCl. We have out MgCl plus H2. So I have outside H2. So
Teacher,
how can
can
I
I say it?
balance? Yes, Yara.
I think it's going to be Mg2Cl plus H2.
This one is MgCl2. So I have outside Cl2 and H2. So only one thing you are going to do. Is it? Yes. So you can see it well. We have 2 chlorine and 2 hydrogen comes out. Here we have 1 and 1. So what are you going to do?
Oh, I remember now. Okay, I'm going to do 1 plus 2 and 1 plus 2, right?
1 plus 2. We must have the same number of elements enter the reaction equal to the same number of elements comes out from the reaction, right? So I have entered in the reaction 1 hydrogen and 1 chlorine here. It's hydrogen chloride, but here I have outside 2 chlorine and 2 hydrogen. So I'm going just to add 2 here. So I have 2 hydrogen and 2 chlorine. They enter outside. They come outside 2 chlorine and 2 hydrogen.
I
You forgot the
it.
balancing. Yes, yes. So we are starting with the first equation for this term. That's magnesium with hydrochloric acid gives magnesium chloride and hydrogen gas evolve. And if you have the book, just write here number 1. Okay, so we'll count all the equations we are going to take and we will write them in our notebook. So active metals like magnesium and zinc, they are reacting with the dilute acids like hydrochloric acid, forming the salt of the acid and hydrogen gas evolve that burns with a pop sound. Like when we put a match near to it, like if we try just to put a match near to it, it will make pop sound. And this is our detection. Like they can ask you, how could you know that there is hydrogen evolves? It's a gas, we can see it, it's transparent. So you are going to say, we are going to bring some matches and put it near to the test tube after the reaction. Then we are going to hear the sound, pop sound. That comes out because the hydrogen gas evolves. So again, what comes out when the active metal combine with dilute acid or acid? The salt of the acid, like MgCl2, and the hydrogen gas evolve. How could we know the presence of the hydrogen gas? Because it burns with a pop sound on approaching a burning match to it. Okay? Any problem here?
No.
Okay, you say no. Ask now, then you have the right to ask now, then I will ask. So it's up to you. Okay. The reaction of metals, this is the reaction of metals with dilute acids. So knowing already now, once we add active metal to the dilute acid, we have the salt of the acid and the hydrogen gas evolve. Clear?
Yeah. Clear, teacher.
Miss, can you repeat it?
Here we should know that if we add any active metal, okay, when you study the metal or when you listen to the sessions, you are going to know we took already metals. So any of these metals that is active, and we add to it some acid, dilute acid, so they will react together. What will happen when they react together? They will form a magnesium chloride salt or whatever the metal is, the metal salt, okay, and hydrogen gas evolve. How could we know the presence of this hydrogen gas? We are approaching a match to it near to the test tube, so it will burn with a pop sound. It will make a pop sound when we approach it to the test tube. That's why we will know that the evolving of the hydrogen gas. And we have to know the equation, Mg plus HCl give me MgCl2 plus H2. Okay?
Okay.
Okay. How about the action with oxygen? What happens if we put the magnesium strap with a jar filled with oxygen gas? Like we bring a jar filled with oxygen gas and put the magnesium strip inside it. What will happen? Of course, the magnesium strip will burn with a bright light and they change into powder. I think this one that we made yesterday.
Yeah, this
last year.
one for the valency. We took it last
Valency?
year. No, not for the valency, but we took it last year.
Yes, I know.
That will
we
change
took it
into a
last year.
white powder.
Yes, and we
Yeah.
made Salma and Yara. Do you remember this experiment? We made it, by the way.
You
Okay.
made it in the real life?
Yes.
Really? Oh, I like
I will
to
try.
make it
I
like
will try, inshallah, to make it this year as well. But when I bring some magnesium first. So magnesium strip burns with a bright light. It makes like a bright light. It's amazing, Yani, and it change into white powder. What is this white powder? It's the magnesium oxide. Okay, and so the magnesium oxide, even when we add some water to the produced substance, we have already white powder. Then we are going to add some water to this white powder and shake well to see what will happen. They will dissolve or no. Okay, so the magnesium oxide dissolve in water and the solution turns into blue because we are going to try to add some litmus solution. Do you remember the litmus solution or no? That we are detecting the pH with it. We took it last year as well. Okay, let's revise it.
teacher, can you remind me? I can't remember.
Yes. So there's some detectors like how can we detect the pH of any substance? What is the pH? To know is it acid or base? To know the substance is acid or base. Okay.
This is the paper that have purple and blue parts.
Yes. That's it. We have instead of it, we can use solution. And instead of the paper, we can use solution, litmus solution. Instead of the litmus paper, there is litmus solution. So here they added drops of violet litmus solution. Okay, to see what will happen to the color. They will change or no, or what will happen. So when they add the litmus solution, the solution change into blue. Change into blue means acid or base. Who remember? Acid or base? Yani acid or alkaline or base, but it's
Base.
base. Yes,
I think it's
because
Base, yeah.
yes, and because red and the pink they were acids, so blue is base. Okay. And connected. Playing with my pen online. Yes, it's working. So first, what we are going to do, we are going to just burn one end of the magnesium stripe until it burns. Then we are going to add it with the oxygen. So I'm going to add the magnesium with oxygen. The first thing I'm going to do, I'm going to put the magnesium with oxygen. What will happen? Powder will form. What is this powder? It's magnesium oxide. This is the first step. I have magnesium oxide. This is a white powder. Okay, so I have first the magnesium combined with oxygen. They will react together. So the metal combined with oxygen, forming what? Forming a metal oxide, like magnesium oxide, by heating. This equation is balanced or no? Salma, can you please balance it for us? Salma is quiet today.
I think we'll put then 2.
We'll put 2 where?
It will be 2 MgO.
Yes. So I have here now 2 oxygen. The oxygen, okay. How about magnesium?
We'll also put before magnesium 2.
Very good. So it's 2 Mg plus O2 with heating give me 2 MgO. Very good. So I have here.
Why we add 2?
To balance the equation. We took it last year. like Mg plus O2 give me MgO, right? So how many magnesium entered in the reaction, Judy? It's 1. How many oxygen? It's 2. And outside, I must have the same number of each element that enter in the reaction. So I have outside MgO. So how many magnesium I have? It's 1, okay. But oxygen enter 2 and outside is 1. So I have to make the oxygen 2 because it's here 2. But when I made oxygen 2, the magnesium now is 2 as well. So I'm going to add here 2. So here I have 2 and 2 and 2. They are balanced. Don't you remember it from last year?
And I remembered, but I can't add 2 here.
Where? No, this 2, it's now playing with it. Because for example, the oxygen is diatomic. Oxygen diatomic, it means the oxygen molecule is already 2 atoms, but the magnesium is only 1 atom. I can't play with it. It's something according to the nature. Oxygen already found in the nature, combining 2 atoms together. Magnesium only 1. No, we can't add here. Okay?
Yeah, of course.
So this is the first step, the combining between the metal and oxygen. I have metal oxide. Then I'm going to try to take this powder and add it with the water to see what will happen, like we did. So we will have something basic, like we said, or alkaline. So it is MgOH by 2. If you remember, OH, the hydroxide
Magnesium
group.
hydroxide.
Excellent. It's magnesium hydroxide, and it's already balanced this way. So we have MgOH by 2. This is magnesium hydroxide. And it is alkaline.
Why here I can't add before magnesium 2? Before
What should I add? Yes, why should I add 2? It's already here 1 and it's here 1.
It's balanced already.
Yes, I have here oxygen 2, I have here oxygen 2. Hydrogen 2, and I have hydrogen 2. It's balanced, all of them.
No, why I can't the equation will be 2 MgHO only.
What? Oh, what?
Like we did below.
This one, it's magnesium oxide. It's magnesium oxide. Magnesium, its valency is +2, oxygen -2. So when they combine together, it's MgO. Let's see here. Magnesium is +2. Oxide, negative only 1. It's monovalent. All of this also, it was in last year. So when they combine together, the magnesium 2 and hydroxyl 1. So we are making the scissor. So magnesium takes the 1 and the hydroxyl group takes the 2. So we have here 2. And we can't play with it. It's related to the number of atoms inside the compound.
Yeah, okay.
All right. Now let's understand what does it mean, the word alkali. We already know basic. Last year we took something acid, something base. What is alkali? They said that when base dissolve in water, it is called alkali. So if the base not dissolve in water, it's not alkali. It's not alkaline. But the alkaline is the base that dissolve in water. So when we tried here to dissolve the magnesium oxide in water, it makes magnesium hydroxide and it's already soluble in water. So that's why it's called alkaline. That's why we are saying not, or all bases are not alkaline. Why? Because not all bases dissolve in water. Again, why? Or give reason. All bases not alkalis. Why? Because alkalis are bases that dissolve in water, and not all bases dissolve in water. Okay? Is it clear, this part?
Yeah.
About the silence that we have from Farah and Salma today. Clear?
Yes, teacher, معاك
Yes, it's
هنا.
clear.
Okay. Right. Let's read it. We have metals like magnesium react with oxygen forming what? Metal oxide. They are forming metal oxide. That's known by basic oxides. Basic oxides, because we already know that the litmus paper or litmus solution change into blue. So what are the basic oxides? They are the metallic oxides. Some of them dissolve in water, forming alkaline solution. When they dissolve in water, they form alkaline solution. So we already know now basic oxide comes from metals or non-metals? Metals. Because when we take non-metals, there will be something different. So when metal combine with oxygen, by heating, they will give me basic oxide, like magnesium. When it combines with oxygen, so it will be magnesium oxide. Some basic oxides, such as magnesium oxide, dissolve in water, forming what? Alkaline solution. That it change the litmus solution into blue. So if we have the magnesium oxide, now this equation is number 2, this equation is number 3. Magnesium oxide.
Where we can find this paper?
What?
I want to buy this paper. Where we can find this litmus paper?
I'm not sure because I have lab. That's why I can buy this kind of things. But if you don't have lab, it will be very hard to find it.
Yeah, I think that we must like having rukhsa or something like that.
Yes. Okay. So magnesium. Okay. What, Yara?
They're talking to you in the group.
Oh.
Yeah, I think that teacher, did you send the link of the science group or the link of the period itself?
And teacher, you send the link of the العلوم, not science, right? In the group.
Yes, I sent it for Muhammad. Is it
They're
wrong?
saying it's not working. Yeah, they're saying it's not working.
Astaghfirullah. Yeah, I'm sorry, Wallah. I'm very sorry for him. Okay, I'm going to check. Alhamdulillah, they fixed the problem, I think. Okay. So it means that I made all this problem, huh?
Teacher, I think that Muhammad
Wallah,
is
I just wanted
in the
to help.
Arabic section.
I know. I sent him the other link to join the subject.
Yeah, our link.
Not our link.
Language.
No, I sent him the other one. I didn't know that there's a
بعتت لمحمد اللينك بتاع العربي مش الإنجليزي، مش اللغات يعني.
هو أساسا محمد لغات ولا عربي؟
عربي.
إن شاء الله. You don't know. Okay.
طيب مش مهم، أنا مش فاهم.
يلا okay. Whatever. Alhamdulillah, the problem solved, so no problem. Magnesium oxide, when combined with water, it forms magnesium hydroxide, and this is the alkaline solution, or this is the alkaline. Okay, so alkaline solution change the litmus paper into, or the litmus solution into blue. Yes. Yes, we have here all bases aren't considered alkalis. Why? Look here, all these bases, this yellow circle is bases, so only some of them are alkalis. What are alkalis? The bases that dissolve in water. So if some of the bases dissolve in water, it means that they already dissolve in water. They are not all bases because not all of them dissolve in water. Okay? This part is clear? Okay.
Yeah.
Now, time to ask you. Because I gave you a chance to ask me, you didn't. I will ask you. All right. I'm going to start with Farah. So, Farah, tell me what happens when active metal combine with dilute hydrochloric or the dilute hydrochloric acid. What happens?
Teacher?
Yes.
Can I go for a minute?
Minute? Okay.
Okay, thank you.
Be fast because I will ask you.
السؤال
يعني what happens when active metal combine with dilute hydrochloric acid? What happens when magnesium combine with hydrochloric acid? Complete the equation.
I'm sorry, I was eating.
He was eating in the science session as last time. Okay, that's great.
Teacher, I think that they eat in every session. Also, they eat in English session.
يعني no problem, but يعني eat and focus. يعني right? That's why you will answer it, Farah.
I think she can talk.
Okay, I will answer.
Yes.
well,
أيوة.
يعني الجواب المفروض يبقى يعني جملة ولا يعني
No, you are going to tell me what will come out from the reaction. Two things here.
magnesium chloride and hydrogen gas.
Yes. So how can I write them?
MgCl,
MgCl2
and H2.
and H2. Yeah, both. Very good.
I know
Yes.
that teacher, if I wouldn't see it, you would fight with me, I know.
That's why you look at the book or you answered by yourself?
No, I don't have the book.
Alhamdulillah. Yes, that's amazing.
Teacher, I think
Thank
that
you.
all of us don't have the book.
Oh, yes.
Yeah.
Okay.
Yeah, because we didn't buy
أنا بذاكر
the old
من
one.
الPDF.
Waiting
أنا
for the
Yes,
new one.
yes. Okay, that's amazing. So Farah, you are free.
قصدي احنا هنضل يعني الكتاب ما نزلش في المكتبة لحد دلوقتي احنا هنضل كده يعني ولا ايه؟
إن شاء الله
I think that
يعني
you are completing with
المواد
2021.
بتتأخر دايما.
لا this year is different as well but okay إن شاء الله maximum 10 days يعني إن شاء الله. Okay.
Oh, okay.
So let's complete and Farah you are free to eat, you already answered. Now Yara. Yara, what
Yes,
happens when the metal combine with oxygen?
Metal combines with oxygen. That's confusing. Okay, I think it's going to be MgO, but I didn't put the numbers.
That's right. What is this MgO?
It's magnesium oxide.
Yes, magnesium oxide. So we have the and it is called magnesium oxide, and we are calling it because it changed into blue. So it is basic.
Alkali.
Basic oxide. This one is basic oxide. Now, we didn't try to dissolve it in water, so it's basic oxide. Okay. So this is a basic oxide. The metallic oxide itself is basic oxide. Right.
Okay,
Some of them dissolve in water, called alkaline solution. Thank you, Yor. And of course, it's not balanced. Yeah.
So can I balance it?
Okay. And Judy. So Judy, if we try to dissolve the magnesium oxide in water, will it dissolve or no? The basic oxide dissolve in water or no? Some of them, yes. Like magnesium oxide dissolve. Then what we will have here?
Mg and in brackets OH2.
Very good. Do you know what is its name? What is its name?
Magnesium alkali.
It's magnesium hydroxide. And it is alkaline. Yes. So it's magnesium hydroxide and it is alkaline or alkaline.
Is alkaline the metal that dissolves in water?
It is the basic oxide that dissolves in water. Okay, but generally, Salma, if we're not speaking, for example, if we're not speaking about metals, so alkalis, they are any base that dissolve in water. And the base that dissolve in water is called the alkaline. Okay.
Yeah, but here we are talking about metals.
Now we are speaking about the basic oxide that is formed from the combination between the metal and the oxygen. They dissolve in water, so they are called alkali. And not all of them also dissolve in water. Okay, so the basic oxides, they are the metallic oxides or the metal oxide that some of them dissolve in water, forming alkaline solution. So, Salma, so if I ask you, all bases are alkalis, true or false?
False, because some base doesn't dissolve in water.
Yes, very good. Sorry. And thank you, Shaht.
Yes, teacher.
What can we see if we try to put a burned magnesium stripe into the oxygen or a bottle filled with oxygen?
A white powder.
Suddenly? They pour the white powder. Like bright light. Before the white powder, first we see that it will burn with a bright light.
Bright light and it will change into the white powder.
Yes, very good. And then, okay, this round, you win. Let's see the second one. Me against you today. Okay. Chemical activity series. This one, it's easy. Okay. We are going to take it, inshallah, in details in grade 10. But this year, we're just going to take a hint about it. The chemical activity series. The scientists said, how could we know which element is active or not? How could we know which element is more active than the other? Then they made their experiments and they already decided which element is more active than the other, and they made them in a chemical activity series, something like a table. Starting with the most active element and ending by the most inactive element. We are not going to take them all, we are just going to take like examples. So metals are arranged according to the degree of their chemical activity in a series called chemical activity series. What is it? It is the arrangement of metals in a descending order, because I'm starting with the most active one. In descending order according to the degree of their chemical activities. And here we go. This is an example or a part of it. Ziad, good morning. You are with us in science? Guys, is he your friend?
No, teacher, I don't think.
No.
So, Ziad, how are you? Can you hear me?
I think he came by mistake or he entered with another account, maybe.
Okay, so when he wants to answer, we can then. So we have here the metals and the degree of the chemical activity series. When we move from up to down, decreases, because I'm starting with the most active one. And you already know potassium and sodium, the most active metals. And you already know what happens when we put a piece of sodium or a piece of potassium in the water. Yani explosion happens. So this is the reaction with water. So for example, if we start with potassium and sodium, the most two active metals on our earth, they are potassium and sodium. So they react instantly, means immediately, with water, and the hydrogen gas evolve with burn with a pop sound, the same we made in the first experiment. So once just the sodium touch the water, at the same second, it burns, okay, and make like, we feel that if it's a big piece, so it make explosion and make the pop sound. This pop sound is the hydrogen gas that evolved from the water. But calcium and magnesium, they are reacting, but very slowly. They need a lot of time to react, but they react. And with cold water, not hot one. Okay, so they need a specific temperature. Zinc and iron, they react with hot water. They need a specific temperature. They are reacting with hot water vapor at high temperature only. So in cold water, they are not reacting. Then we have copper and silver. They don't react with water. Whatever we put them, we are wearing gold all the time and silver, nothing happens to them because they are not reacting with water. So what is the chemical activity series? It is the arrangement of metals descendingly according to the degree of their chemical activity. The most active one, we have potassium and sodium. Once they touch the water, they react, and hydrogen gas evolve with a pop sound. Calcium and magnesium need cold water, but they react very slowly. Zinc and iron, they react with hot water vapor at high temperature only. Copper and silver, they don't react with water. Right?
Yeah.
Do you want?
This one is easy.
Okay, so I'm just giving you a few seconds to have a look before I ask you. Don't make a screenshot. Yes.
Okay, teacher.
Okay, I give you the idea. Right, no problem. The last thing before I ask you here, they are saying that they try to clean the silver tools, how they clean it. So they are saying that they are covering
by maybe this one called 1 minute. I will remember.
They are using the foil. They are using the aluminum paper, you know, the foil that we are using in the kitchen.
Yeah.
They are covering the plastic plate. How they make it? They covering the plastic plate with this foil, and they make the bright surface upwards. Then they pour the boiling water in the plate. Then they add 3 spoons of baking powder. So they will be sure that the reaction happens. This is about the silver. So they immerse the silver tools with which you want to clean in the water, then leave the tools for 15 minutes. They will already know that whatever happens, they will not react with water because they are silver. Then they dry the tools after rinsing them with the boiling water, then polish them with a piece of wool. It's shiny again. So you can use like boiling water with baking powder, then your ring or your whatever silver will be shiny again. Okay, and no worries because there is no reaction happens. Why they are saying that my sharing is paused? You can see my share screen?
No, we can't.
No, we can see it.
No, we can't.
This is the point. All right. And this time, Yara?
Yes, teacher.
We have Fatima. I'm sorry, I just saw her. Fatima, good morning.
Morning, ma'am.
Is this your first time with us?
Yeah, this is my first time.
Yeah. Did you start in science before or was it the first time as well?
You mean I started in science in this academy?
No. Even in another one or by yourself.
Oh, of course. Of course, I did science before.
Yes, alhamdulillah. So how many lessons you finished?
No, and this year I finished like, I think only one. It was about mandaleaves and muesli.
Okay, that's good. We are in the second one, so I can send you the recorded sessions so you can listen to them so you can complete with the session.
The video
okay, that's perfect. Okay. Welcome, Fatima, with us.
Thank you.
Okay, so it was yours turn. Yara, it depends on your memory, the questions now. What are some metals that react slowly with cold water? Yes, Yara.
What metals what?
react slowly with cold water?
Maybe nitrogen.
Yeah. Nitrogen.
I
Are
can't
you sure?
remember.
Yes,
Yeah.
that's why I told you have a look. Okay.
Is
Right.
it litmus solution?
What?
Is it the litmus solution?
No. I'm asking about. I'm asking Yara about the metals in the chemical activity series that we just took. That started with potassium and sodium, then calcium, magnesium, then zinc and iron, then copper and silver. Okay.
Oh.
So, all right. I will change the question, but who knows this one? React slowly with cold water. Judy.
Calcium and magnesium.
Yes, very good.
Yeah,
Calcium and magnesium.
the blue
Yes.
elements.
Yes, that's very good to combine them with the color. Wallah, it's helping in memorizing
Yeah, I was
them.
remembering the color of it, but the symbol itself or the element itself, I can't remember.
Now it's not helping. Okay, Yara, how about the elements that immediately react with water once they touch the water?
Potassium and sodium.
Yes, I think this one you can't forget it.
Yeah.
Okay, Salma, the one that react only at high temperature with hot water vapor.
Zinc and something else.
Yes, it's zinc and something else.
I just said it.
Starts with Fe. What is Fe?
Iron.
Yes, it's zinc and iron, the orange color. And Farah, they don't react with water. The easiest one.
Copper and silver.
Copper and silver and gold. Okay, very good. Who didn't answer yet?
Shahd.
That.
Yeah.
Shahd will ask questions. Okay, Shahd, take this one. What is the chemical activity series? Yes, Fatima, we finished the session. The session is finished. That's why I'm not sharing. It is like arrangement.
It's the descending order for the
Yes.
from the most activity metals to the lowest activity metals.
Yes. It is the arrangement of metals in descending order according to the degree of the chemical activity. Yes, very good. Now we are done with the chemical properties of metals. We took only 3 equations today. You are going to write them in your copybook that we started the activity in. By the way, you can do the third activity we had. You can make it. So our homework to write for me the chemical equations in your copybook. And let's have another one. Study it very well.
Miss, you will send us the homework in a message, right?
Who is asking? Judy?
You'll send us the homework in a message, right?
I think today that's enough to just write the equations in the copybook. And if you want to complete one of the activities we had, you can. Yes, Fatima was asking something.
I was asking if there is any homework, can you send it on WhatsApp?
But you didn't attend the session. You will be able to do it?
I'm going to see the session if
okay.
Egypt,
okay.
so I don't know if the internet is good or what.
Okay, even the session is